Good evening everyone, welcome to Shore of Sales classes. Hope you all are fine. Nice to meet you again. So today our topic of discussion will be something as usual. But before our topic of discussion, let me ask this interesting mathematical puzzle to you. What is the puzzle? Suppose you have got a job in an egg pebble manufacturing company. So the egg pebble manufacturing company makes pebbles in form of eggs. So you are hired there as an optimizer instructor, though there is no such post, but let's create it out of the sake of the riddle that there is a post known as the optimization instructor whose work is to mention the optimum way to do the problems. Now what does the term optimum means? Optimum means the safest, the way with the most minimum cost, not always, but the way with minimum waste of resources. That's called an optimal way. You can define an optimal way as a way in which we can do a work, a way to do a work in which we utilize minimum amount of resources. So you are hired as an optimal manager and the company has produced eggs. So you need to find the power of the eggs, so the power of n eggs as given here. So you need to find the power of n eggs. So how to test the power of egg? The power of egg is tested in the following procedure. So you are there will be a machine that will just release the egg. There will be float tiles like this placed one on top of the other. So one tile, another tile, another tile, another tile, another tile. So there will be the floors will be placed, and your work is to determine the optimal way. So when is the egg said to be strong? If the egg is said to be strong if on dropping the egg pebble the floor breaks, and egg is said to be weak in on dropping the egg pebble the pebble breaks, and the egg and the floor both are said to be safe if none of them breaks, or if only the egg breaks. That is said to be the safe position. So you just remove the weaker condition. So there are two conditions as I have mentioned again. You drop an egg. If the floor breaks, then it's over. If the floor doesn't break, then you can say the floor is marked safe. If the floor breaks, then the floor is marked unsafe. Okay. So you are given n eggs from the company. The company manager suddenly calls you and he gives you n eggs and k floors. You are given k floors here. And I'm not telling anything, so of course you can understand that k must be less than n. This is because if k is greater than n, then that puzzle does not make sense all the time. So you have two eggs and the first floor breaks and you have only one floor, so you cannot do the testing. So your manager comes and tells that Mr. Optimal Manager, please do the thing that I've instructed. So you have n eggs and k floors. So the manager has told you in strict terms that you have to find the most optimum way, that is the minimum resources you can spend. So how did the manager put a check on you that you have to put the minimum resources? So the question is, consider given the n eggs you are given and the k floors, find the minimum number of trials needed in the worst case to find the floor below which all the floors are safe. So I have defined a floor is said to be safe if dropping an egg from it does not break the egg. So in that case the floor is said to be safe as I have defined. So how do you think? As an optimal manager you must have a solution to this problem. But not right now. You are not well equipped with things to solve this problem, but I believe that after this chapter, after this live class, you can easily solve this problem by yourself. So please take a look at the question that I am giving. So, welcome everyone. Today our topic of discussion is binomial coefficients. So before discussing what binomial coefficients exactly are or what we basically do with the binomial coefficients, let me get to the groove and grasp the basic things. So before defining binomial coefficients, I will define a very small function, a very cute function with very cute properties. So let me define a very small function. So I just want to define a function which I personally call myself. You can name anything else you like. You will probably learn something else in every places, but I personally think that if you name the things you like, then it will be much easier for you to remember. remember that at the end of the day, it's not the names that matter. A name is just a name. Even William Shakespeare quoted that what's in a name. So name does not matter. The thing that is matter is how you remember things. So you must remember this, that I call this the choose function. So I call this the choose function. So this choose function basically says us that is nck. So the function is a two variable function. I get it as f of nck is equals nck. So what does this choose function mean? So this choose function says that where if n and k are positive integers, let me write it a bit clearly. So if n and k are positive integers, I define the choose function in f of n and k as n choose k. I call it as n choose k, which means that you are given with n objects and you have to select k objects. Not only that, in how many ways can you select k objects out of the n objects? So this is basically the choose function. So let me give you an example. So what can be 4 choose 2? So 4 choose 2 means I have to select 2 objects out of 4 objects. So how can I do that? So that the doing is very simple. I take 4 balls and label them as A, B, C and D. So I choose 4 balls and I label them as, so let me draw it a bit clarified, in a bit clarified way. So I take 4 balls, so I take A, B, C and D. Okay, so there are 4 balls and what I need to do is from these 4 balls is I need to pick up any 2 of them. So how can I pick up any 2 of them? So if I pick, say I can pick A, B, I can pick B, C, I can pick A, D, whatever. So our work is to count the number of ways how we can choose it. So what I can pick is A, B, I can pick up. So let me write what I am picking. A, B, I can pick up A, C, I can pick up A, D. So these are the only possible choices with A. Remember that picking up BA is considered to be same as picking up AB. I define this repeatedly that picking up the BA is usually considered to be same as picking up AB in this function. Later I'll express you into another function which will of course say that picking up BA is not as same as picking up AB. So this is the choose function. So how we can do it? I have started with A, so I can pick up AP, AC, AD, and from B, if I start with B, I can pick up BC, I can pick up BD. So that's the only the way. I cannot pick up BA because already AB is chosen and that's what I have counted. If I start with C, I can do only CD. Remember, I cannot do CB or CA because already AC and BC are listed. So, and how many ways can I do it? Just count it. 1, 2, 3, 4, 5 and 6. So just see, I am just marking it. If you want, you can just pause the video and understand it. So what we are doing in the choose function is we are choosing from 4 objects, we are choosing 2 objects. We are finding the number of ways, in how many ways we can choose 2 objects from a set of 4 objects. So what I do, I did a set of 4 objects A, B, C, D and I made a graphical procedure, and what I did was, how did I choose? AB is a way, AC is a way, AD is a way, BC is a way, BD is a way and CD is another way. So similarly I can choose it from, say I can make it say 4C3. So how many ways can I pick 3 objects from 4? So I just request you to please pause the video for once and just try this out, just like the table that I have made in the column. So I hope you guys have already created the table. So let me create it for you so that you can just tally it. So I have taken, so now my choose function works for 4C3. So what I did was I again named the objects as A, B, C and D. Okay, so how many ways can I choose? I have chosen A, B, C. I can choose. With A I can choose A, B, C. I can choose A, B, D. So with A there is only two choices, A, B, C and A, B, D. So with A there is only two choices. How many choices I can pick up with B? So I can pick up from B with B, C, D. So there is only one choice. So you can see that if I choose from A, B, C, D, from A I have only two choices, A, B, I can pick up A, B, D, or I can pick up A, B, C. So this is the choose function, so I write it as f of 4, 3 equals to what? So during the choose function, I do it as, so in two ways I can do this, and in one way I can do this. Not only in one way, I can choose B, C, D, and I can also choose B, D, C. So we have observed that f of 4, 3 is 4. So this is all about the choose function that I have discussed about. So you can also see, and you can try it with many things. You can try it with, say, 5C4, 5C3. You can try it with, say, choosing 20 objects out of 30 objects. You can try it on, and you have to just have to visualize this table and just have to visualize this concept so that you can get more into the groove of the next. Now, getting into binomial coefficients, so I first need to mention that what is a binomial. So every one of you here is aware that what is a binomial. A binomial is a polynomial expression, an algebraic expression that contains only two terms. You already know what the binomial theorem is. So this choose function is basically the coefficients of the binomial expansion. So what is a binomial expansion and what is the binomial theorem? So a binomial theorem states that a plus b whole to the power of n is summation of k equals to 0 to n nck a power k b power n minus k. So this is the binomial theorem. Please take a good look at it, what the binomial theorem is trying to state. So just copy it down. So this theorem was proved by Blaise Pascal and Isaac Newton independently. So as I said, so how to prove this theorem? So I use a very shorter technique to prove this theorem so that you can prove things in a very simple way. What you need is just a mental calculation to prove this theorem. I can prove this theorem in one line, and that is what my intention is to show you guys today. So you know that what does a power n means in general. So what do a power n mean in general? A power of n. So a power of a means 1 times 2 times 3 times 4 up to 8. Sorry, a power of n means a into a into a into a. So up to. So a power of a means basically a multiplied n times. So a power of a basically means a multiplied n times. So you can see that 2 power n, 3 power n, 4 power m all have the same power. So this is what a power n means, multiplying a repeatedly. So tell me by common sense that what does a plus b whole power n means? What does it mean? It means a plus b multiplied n times. So we just need to multiply n times. So multiply this n times. But isn't this a very large product to calculate? What do you think? So if you are given say 100 times, say 200 times, say 600 times, can you do this calculation? Of course you can, by the simple method of trick that I will show you. So let me show you the trick. Now suppose forget about a plus b whole power n. Just forget this thing. Now let's get a new binomial, say x plus y. And I multiply it by some binomial, say z plus c. So I multiply these two. So what is the shortcut way of multiplication that I usually teach? The thing is that from the first bracket you pick x, multiply it by two terms of the last bracket. So what you get is xz plus xc. Take the second term, because the first term, the work of the first term is over, just rub out the first term. Take the second term, what you get? Yz plus yc. So that is what we usually do in the multiplication part. So we just pick up the bracket. So this is basically the way I was about to teach you. Now let me exploit this way, just this way, and a form of a simple trick that how can we multiply three binomials out of this. So suppose x plus y is there, z plus c is there, and I take another binomial, say a plus b, for example. Now what do? I'll follow the same procedure again. I take x from the first bracket and write it as x. So when I take x from the first bracket, I just forget the y part. Then I take z from the second bracket, the first term from the second bracket. So what it becomes xz. And from after xz, after we cancel two terms, we have these two terms left. So xza plus xzb. Okay? Now since the work of z is over, now we need to get to the work of c. Just remember this, that first comes the work of first term, then comes the work of second term. First comes the work of first term, then comes the work of second term. First comes the work of first term, and then comes the work of second term. So we will use this work method. So the work of z is over, means the work of first term is over, but the work of first term here is still now not over. So we take x, the first term. So now the second term will work. So xc plus the work of first term is a. xc multiplied the work of second term is b. Okay? So finally the work of first term is over, the work of second term is over. So the work of first term is over, the work of second term is over. And the work of second term here is still left. So what I can do here is the work of second term. So when it comes to the work of second term, so work of second term into, from this bracket, the work of first term. So this bracket, the work of first term plus the work of second term. Again, the work of first term is over. So the work y into the work of second term into the work of first term plus y into the work of second term into the work of first term. So you just have to check work of first term is over, work of second term is over. Just check like this. Work of first term with x is over. Work of second term with y is over. Work of first term with z is over. Work of second term with c is over. Work of first term with a is over. Work of second term with b is over. So I hope you can get into the grasp of the multiplication. In case you did not, so let me consider another example in which I take out four terms. So in this fourth term, I will do it as a plus b into b into, say, not b, so I take it c plus d into e plus f plus g plus h. So I take four binomials now and I'll show you that how can we use this simplified work 1 work 2 method to multiply this. So what did I say? So the first comes the work of the first bracket. So the first bracket, work of the first bracket, first term, work of 1 plus work of into work of 1 into work of 1 from the third bracket into work of 2 from the last bracket. So again, work of 1, work of 2, second bracket, first term, work of 1 from the third bracket, and work of second term from the second bracket. So the work of A is over and the work of G is also over, but here the works are still left. So again, the work of the first term here, the work of C is over, the first term, so I need to work of first term, second term of the second bracket, work of first term from the third bracket, work of first term from the fourth bracket, plus work of first term from the first bracket, work of second term from the second bracket, work of first term from the third bracket, and work of second term from the fourth bracket. Okay, I continue writing that this again comes into work of first term from the first bracket, work of the first bracket and the second bracket have exhausted, so work of first term from the second bracket, first bracket and the second bracket have exhausted, so this is the expression I get only with the work of the first term. So A, C, E, G, A, C, E, H, A, D. So the work of the second term from the third bracket is left. So A, C, so first bracket, A, C, F, G, F, G plus A, C, F, H. Just see the speed at which I can write the expansion of this from this work method. So I can just say that H. Now you might say that still the B is left, so no problem in what the B is left. So you just get this expression, you just add it, write a plus here, and write this entire thing bracketed with just the A's replaced by the B's, and you can finally generate everything here. So this work method for multiplication is really a very useful method, which I'll use to prove the binomial results, the binomial theorem I stated. And of course, along with the choose function that I have defined, I'll use both of this to work out the binomial theorem. So let's see. So A plus B to the power of n, what does it mean? It means A plus B up to n terms. So it means up to n terms, so we can visualize n terms. Just place the n terms A plus B, A plus B, A plus B, A plus B up to the n terms in front of your eyes, and just think that in here the power of A will be increased. Of course, the power of A cannot be more than n. We have learned in the properties of the polynomials. So the power of A cannot be more than n. So you can see that if the power of A is from n minus k, then what must be the power of B? There are only two terms. So if one quantity consumes n minus k, then what must the other quantity consume? N minus k. So that is n gets cancelled out. So it takes n minus of n minus k. So n minus n plus k. The n gets cancelled out and you are left only with k. So what must be the power of B? The power of B must be k. Now, what is the way, in how many ways we can choose n minus k from these n brackets? Can you answer? Of course you can. This is because I have enlightened you about the choose function. So if I apply the choose function, what does it become? I have to choose n minus k out of n brackets. So, choose n minus k, or you can also write it as I have described in the choose function, f of n comma n minus k, a power n minus k into b power k. So this is the choose function representation. Now I want to tell you a very important thing about the choose function. Now suppose you have two terms, and from these two terms the number of ways of selecting n minus k must be the same of number of selecting b power k objects. Why not? This is because if you are choosing n minus k, you are left only with k objects. So you can always state that the choose function for number of ways of this is equal to the choose function of number of ways of this. So I hope it's clear by now. By the property of the choose function is clear by now. So from here I can directly write f of n c k, n comma k, a power n minus k, b power k. So n c k, so what we write at n choose k, this was the notation chosen for our choose function. So this is what we have concluded, and we have just saw that the coefficient of this is this. Now what if the n minus k, this n minus k can be anything and every term is included. N minus k can be 0, n minus k can be 1, n minus k can be 2. So what is the best way to represent it? Yes, you have got it. The best way to represent it is just apply the summation notation from k to 0 to n. And I have proven the binomial theorem in just a single line using the concept of choose function and the concept of shorthand multiplication, the work method. So you can see that how powerful it is. It can prove the binomial theorem in just a single line. So you can see that the proof is over and I didn't have to write anything except the extra additional notes. So this is just a one-line proof of the binomial theorem. Now what I am going to discuss is binomial coefficients. Now these f of n comma k, the parts of the choose function, observe that these form the coefficients of the terms here. Now since these are the coefficients of the terms of the binomial expansion, so we usually prefer to call it as binomial coefficients, which we are going to learn it today. So I'll just pause the video to let you understand the concepts in a grasp. So now, as we have studied a lot about binomial theorems and the binomial coefficients, so now I will list some properties of the binomial coefficients. So what are the properties? So the properties is, first property is nc1 plus nc2 plus plus ncn is. So this is the first property of the binomial coefficient that we have to prove. So this is the first property. So I request you guys, everyone, to pause the video and just to attempt the proof of it and later tally on it with me. So you can just see the question there. So this is the first question and the first property that we have to prove, that the sum of all the binomial coefficients is 2 to the power of n. Now, so I hope that you all have succeeded in proving this. So now let me prove it. So the proof of the first property. So proof of the first property is as follows. This is the proof. So now we know, we start directly from the binomial theorem. So the binomial theorem is a plus b whole to the power n plus nc0. Now what we need for the first property, for proving the first property, we need nc0, we need nc1. Remember that I have introduced the new notation here. nc1 here means, of course, our choose function. This is another way to represent our choose function. What we have done, f of n comma 1, or this is f of, say, n1. Okay, so I hope it's clear right now. So now what do we need actually to prove the first property? So what we need actually to prove the first property is only these coefficients. Only these coefficients with these terms vanished. I don't need the a and b. Remember, if you remember the first property, if you have copied it, then there were no a and b in the first property. But these a and b are present in multiplication terms. So I must find a suitable value for a and b so that this holds. So this is the intuition behind the question. As I have always explained, that intuition is the key to solving question. Intuition is the key to solving questions. You must first have an intuition before going to the detailed proof. But never make this mistake that your intuition written down in form of words cannot be treated as a formal regular proof. Remember this properly. So what is our intuition? What was the intuition we developed? So let me write it as, so what was the intuition we developed? So the intuition was, we don't need AB. Because we want only NCKs. So So the intuition that was developed is that we want no need of A, B, we don't need A and B, so we want only NC case. This intuition will serve as the proof. And what we want again is that can we choose A, B? So now can we choose A, B independently? Of course, this is because this is a theorem and this is an identity moreover which works for all values of A, B. So we can choose A, B from our will. However we want, we can choose A, B. So the third intuition is we are independent in choosing A, B. In choosing A, B. And these main intuitions will tell us that how must we choose A, B for A, B to vanish? Exactly, because the multiplication term to go, we need to choose both A and B as 1. Now what happens? We choose both A and B as 1. So this is the last intuition, that we choose A equals to B equals to 1. Students, I am telling you that this is a general method to approach any problem. You must develop and point out intuitions like these. You must develop this because these points will later help you to prove any statement or to solve any problem. So we are now well equipped to do the proof. Now how can we prove it? We know that we have to choose A and B equals to 1. So we know that this holds in the second step. If A equal to B equal to 1, choice, then what we get? 1 plus 1 whole to the power n. On the other side, nc0 plus nc1 plus dot plus ncn. What does this become? 1 plus 1 is 2 to the power of n, and the proof is over, as I said. So this is one of the very basic and very important properties of binomial coefficients, and I have taught you that how to use intuition to prove things. Now, so please note down the intuition and see how I have used the technique to prove it. And I recommend everyone to pause the video and just take a look at it and rewind it, the intuition part, so that you can understand the basic senses. So we will get back to the second property of our binomial theorem. The second property says that to C0 plus, not C0, so NC0 plus NC2 plus NC4 plus NC n minus 2 by 2 box, so NC minus 2 plus dot C1, C2, C3, C4 just rub it on. Just NC1 plus which is equals 2 to the power of n minus 1. So the second property says that for odd number of the choice function that we have defined, the odd number of these choose functions, the sum of the even numbered coefficients of the choose function, even number subscripts of the choose function, is equals to sum of odd subscripts of the choose function, which is equals further 2 power n minus 1. So I recommend you to pause this video and try proving it before we get back. Okay, so I hope you all have tried this proof. Now, I hope you have guessed it correctly. So now I will state 2 or 3 more properties without the proof, which you can try to prove in the way I have told. So please do prove these properties. These properties says that C0, NC0 minus NC1 plus NC2 plus, minus rot is 0, 4, NC1 plus 2 NC2 plus 2n into NC2 plus rot So these are the other properties that we will frequently use in the sums. So I request you, all of you, to pause this video and copy these properties. This is because these are the most essential properties that we will use in problem solving. So now every session, as I have said, that every session seems incomplete if we don't solve at least one question. So I encourage you to solve many more questions on binomial and get back to Shorov's classes. So I'll just solve a question for example for your convenience. So what I need is the question here. What I have is 1 plus x whole to the power 15 is equals to a0 plus a1x plus nx power n for all x belongs to real. It is given. Then find sum r equals to 1 r into e to the power r equals to 15. So this is our problem. So it's given that 1 plus x whole power 15 is a0 plus a1x plus dot anx for all x belongs to real numbers. Find this thing. So we need to find the summation of r times r minus 1. The summation runs to r to 15 with a difference of 1. So I request you to pause the video and try it. And next I am giving you the proof so that you can tally your answers with the solution that I give. So proof. So as I have taught you that summation r equals to 1 to 15 r into ar by ar minus 1. So we have already seen from the binomial coefficients that this thing results into 1 into a1 by a0 plus 2 into a2 by a1 plus dot plus 15 into a14 by a15. So as I said, that the intuition is important, and here the intuition directly tells us to use the fourth property that we did, that is C1 by C0, 2 into C1 by C1. So this thing, as we have learned from the fourth property, is direct application of the fourth property is 15 is n into n plus 1 by 2. So you can just substitute the things to the fourth property and you can just get it. So 15 into 15 plus 1 by 2. And this becomes 1. So please pause the video to understand the solution again. So I hope you enjoyed today's class and you can solve the optimizing manager riddle. Don't forget to solve it. So this is all for today. So perhaps we will meet next time. So till then, goodbye and thank you for watching this video.